In this lesson, we're going to discuss solving two-step equations. Let's take a look at a few examples. Example number 1, 3x plus 5 equals 17. Alright, so here we're trying to solve for x. Okay, so this is my variable that I'm solving for. So I want to get my terms with an x on one side of the equation. Here's the equal sign. This equal sign splits two sides. We've got one side to the left, one side to the right. So if you think of this as like a little wall here, a barrier here, I want my terms with an x on one side, the terms without an x, so these guys are the ones without an x, and I want these both on the same side of the equal sign. Now if we notice here, clean this up a little bit, the 5 and the 17 are not on the same side here. So my goal here is to get this 5 over to that side of the equal sign. Well, to cross over the equal sign, I'm going to look at the sign to the left of the number. The sign to the left of this number is a positive. So this is actually a positive 5. So to bring this positive 5 on the opposite side of the equal sign, we're going to do the opposite of adding 5, which would be to subtract 5. So let's start there. So we're going to subtract 5 from both sides. So to get one variable or one number on one side from another, you have to do the opposite. So the opposite of addition is subtraction. I'm going to keep my 3x here. Nothing happens to that. Positive 5 and negative 5, those simplify, so I got 3x equals 17 minus 5, and I get an answer of 12. Okay, getting closer. Again, I'm solving for x, so I want just x equals, my final goal is to get x equals something. Right now I have 3x. Remember, a number next to a variable. These two numbers, or the coefficient in front of the variable, this means operation. The operation is multiplication, so this is like 3 times x, okay? So this is 3 times x, also written as 3x. So if these are attached by multiplication, to detach these, I'm going to do the opposite multiplying, which is division. So I'm going to divide this by 3. If we notice 3 divided by 3 is 1x, and that's exactly what I want, is 1x. But I can't just divide the left side by 3, I also have to divide the right side by 3. So what I do to one side of the equation, I must also do to the other side of the equation. 12 divided by 3, and I get 4. So rather than writing 1x, I can just write x. So x equals 4. If you want to go back and plug 4 into the equation, so 3 times some variable plus 5 equals 17. So this is what I'm plugging in for x here. Well, we said x is equal to 4, so let's take this 4 and plug in for x. So if all is right, then this side should be equal to this side here. So 3 times 4, we get 12 plus 5. 12 plus 5 is 17, and does 17 equal 17? Yes, and there's your check. Okay, let's look at our next example. Negative 4x minus 2 equals negative 10. Okay, again, I'm solving for my term with the x. The negative 2 here does not have an x. The negative 10 does not have an x. So I want both the negative 2 and the 10 on the same side of the equation. So I want to bring the negative 2 over to the right side of the equation. And now let's look at the 2. The sign of the 2 is negative 2, so I'm subtracting 2 on the left side. So the opposite of subtracting 2 would be to add 2 in order to get to the other side. So add 2 to one side, add 2 to the other side, and this will get my 2 over to the other side. So we're going to bring down this negative 4x. Be careful, don't forget your sign, very common mistake. Negative 4x, negative 2, positive 2, see you later, goes away, that's equal to 0, equals, and now negative 10 plus 2 is equal to negative 8. Alright, we're getting closer. I don't want negative 4x equals something. Again, my goal is to get x equals something. So I don't want this negative 4 here in front. Remember, this is like negative 4 times x. So how do I get rid of this negative 4? The opposite of multiplying is dividing, so I'm going to divide by negative 4. So I'm always dividing by the coefficient in front of the variable. And I'm going to divide this side by negative 4. Negative 4 divided by negative 4 is 1x. Negative 8 divided by negative 4 is a positive 2, or just 2. 1x becomes x equals 2. Once you have 1x, you're done. That's exactly what you want to get. Except the 1 is the number that's you don't have to write, okay? So again, first isolate the variables. So the negative 2 did not have a variable. He goes first. Now once I have the terms with variables on one side, the terms without the variables on the other side, look at the negative 4 times x, divide by negative 4, divide the other side by -4, and solve an x equals 2. And again, you could always plug in for x. You could always plug back into your original equation here, plug in for x, and you should verify that you get -10 here. Okay, next example. -3x plus 5 minus 7x equals 25. Okay, so this one's a little bit more detailed. There are two terms here, one and two terms here on the left side that both have an x. So what I want to do first is, since they both have an x, is I just want to combine these two terms. Okay, so so I'm going to rewrite this. I'm going to write these two next to each other. Now this is an extra step you don't have to take, but I'm going to take it for now. -3x, I'm going to bring this -7x next to it, plus 5 equals 25. So all I did was write these two terms next to each other. Okay, and just for a visual, now if you combine these two terms, so we have -3x minus 7x. Well, this is the same thing as just saying -3 minus 7, which is equal to -10. So we're just going to say this is equal to -10x, combining those two. Plus 5 equals 25. So now we have, again, a two-step equation. We're solving for x here. The positive 5 does not have an x. The 25 also does not have an x. So let's get the two numbers without the x on the same side. We can accomplish this by bringing over the positive 5. So let's get this positive 5 over to the left side here. So we're going to subtract 5 from both sides. We're subtracting 5 because it's the opposite of adding 5. So on the left side I'm adding 5. On the right side I'm subtracting 5. Let's bring down my variables here. So I got -10x, positive 5 and -5, see you later, it goes away, equals 25 minus 5, and I get 20. Getting closer, I don't want -10x, I just want x equals something. How do I get rid of this -10? Remember, -10x means -10 times x. The opposite of multiplying is dividing, so I'm going to divide by -10. Divide both sides by -10. -10 divided by -10. Anything divided by itself is always 1, so I got 1x equals 20 divided by 10. -10 is -2. So 1x equals -2, or just x equals -2. Okay, let's take a look at a couple more examples. 6x minus 5 plus 3 equals 10. So now if you notice on this side, I have two numbers here without coefficients on the left side. So I got -5 and positive 3. Both these terms are on the left. Both these terms don't have a coefficient. Therefore, they are both constants and they are both like terms. So I'm going to combine those. So I'm going to say 6x, -5 plus 3 is equal to -2 equals 10. Okay, now we're back to our two-step equation. Again, I'm solving for x. Let's get rid of the -2 first. So let's add 2 to both sides. This works out nicely for us. So bringing down our 6x. 6x, -2 and positive 2, see you later, goes away, equals 10 plus 2, I get 12. I don't want 6x, I just want x. Next, I'm going to get rid of my 6 by dividing by 6. 6 divided by 6 is 1x equals 12 divided by 6 is 2. So rather than 1x equals 2, I'm just going to say x equals 2. Okay, let's take a look at a few more. 6x minus 7 equals -7. Alright, so one step or two-step equation again. I want to get this -7 on the other side, so I got plus 7. Plus 7, I'm adding 7 because it's the opposite of subtracting 7. Let's bring this down, so now I got 6x. -7, positive 7 goes away, equals, and again on this side we have -7 plus and positive 7, that also equals 0. Alright, so this is sometimes a part that gets confusing for many. Just because you're here, now you can say, okay, well, think about this logically. 6 times what is going to equal 0? Well, if you can figure this out from here, well, 6 times 0 will equal 0. If you want to do the algebra behind this, divide both sides by 6. 6 is simplify. 6 divided by 6 is 1x. 0 divided by anything is always going to be 0. So in this case, x equals 0. Okay, next example, 5x plus 2 minus 5x equals -3. Okay, so I'm going to combine my like terms here. I have two terms with an x. I have the 5x and the -5x. If I combine these, 5x minus 5x is actually equal to 0x. So the 0x, or 0 times anything, is just going to be 0. So those go away, and I'm just left with positive 2 equals 3. Now let's look at that statement. Does 2 equal 3? Is that a true statement? So 2 does not equal 3, so this statement is false. So when you get a false statement like this as your final answer, this is an example of a no solution. Okay, this is the symbol for no solution. So no solution on this example. So there is nothing you could plug in for x that will make this statement true. Okay, there is no terms or no real numbers that you could plug in for x that will make this statement true. Again, this is when two sides of the equation do not equal one another. Okay, you're left with nothing but constants. 2 equals 3, that is not a true statement, no solution. Let's take a look at another special case. 8x plus 9 minus 8x equals 0. So now my two like terms here are 8x and negative 8x. Let's combine these two terms. So 8x minus 8x, that also goes away like the last example, except this time I'm left with 9 equals 9. Well, is that true? Does 9 equal 9? The answer is yes. So when you're left with a true statement like this, 9 equals 9, the answer is all real numbers. Or infinite solutions, you can also say. Another word, infinite solutions. So no matter what you plug in for x, both sides will always equal one another. Symbol for all real numbers, two parallel lines, and you make your R here. This is a symbol for all real numbers. Okay, a couple more examples. Alright, so now we have some division. X divided by 3 plus 5 equals negative 2. So this is just like the last examples we've done. So 3x plus 5 equals negative 2. So the first thing we did was get rid of the number without the variable. So we're going to do the same approach here. Okay, the x divided by 3, this term has a variable, so let's leave him alone for a second. Positive 5 and negative 2 both do not have variables, so let's get this positive 5 on the left side here. And we're going to do that by the opposite of adding 5, which again is subtracting 5. Okay, let's bring this down. So now let's bring down this term. So we get x divided by 3, positive 5, negative 5, see you later, equals negative 2 minus 5 is negative 7. Okay, so be careful there. So negative 2 minus 5 is equal to negative 7. Alright, so x divided by 3 equals negative 7. I don't want this x divided by 3. Again, I just want x equals something. Now since I'm dividing by 3 here, the question you have to ask yourself is, what is the opposite of dividing by 3? Well, if you said multiplying by 3, then you are correct. So the opposite of dividing by 3 is actually multiplying this by 3. But remember, what I do to one side, I must do to the other side. So I need to multiply the right side also by 3. And now you have 3 over 1 times x over 3. So here are 3 simplify, and you're just left with x, or 1x. So we got 1x equals, and then here you got negative 7 times 3, which is equal to negative 21. So our final answer is x is equal to negative 21. Let's take a look at another example like that one. Similar, so this time I have a quantity on top, x plus 3 divided by 2 minus 5 equals 7. Alright, so since the whole quantity is on top, okay, we're going to leave that on top there. So we want to still get rid of this negative 5 first. This has nothing to do with the fraction, has nothing to do with the variable. It's just a constant on its own. So let's get this negative 5 over to the other side. How do we get this negative 5 on the other side? If you said add 5, you are correct. So add 5 to both sides. Okay, bringing this down. So we got x plus 3, the quantity of x plus 3 divided by 2. Those go away. See you later. And 7 plus 5 is 12. Alright, we're getting closer. So now my next focus is how do I get rid of this dividing by 2 here? Alright, so I want to get this x plus 3 all by itself without any division sign underneath it. So this is dividing by 2, which the opposite of dividing by 2 again is going to be multiplying by 2. What I do to one side, do to the other side. So let's multiply this side by 2. My 2's here will simplify, and I'm just left with x plus 3 equals 12 times 2, which is 24. Alright, I'm getting closer. I don't want x plus 3 equals 24. Again, I just want x equals something. So how do I get this positive 3 on the right side of the equation? Okay, very good. If you said subtract 3, you're exactly right. So now we have bringing down my x equals positive 3, negative 3. See you later. 24 minus 3 is 21. Here x equals 21. Okay, let's look at another one. Very similar. 2x minus 4 over 5 plus 3 equals 8. So again, I'm going to put this in parentheses. Okay, so my goal is to get that by itself without the positive 3 here and without this 5 here on the bottom. Alright, so let's get rid of the term that has nothing to do with the variable. So let's get this positive 3 on the right side of the equation. So again, I'm getting rid of this positive 3 because it has nothing to do with this piece here, this 2x minus 4 divided by 5. Alright, I'm going to attack that last. So subtract 3 from both sides. Okay, bring this whole term down. So I got 2x minus 4 divided by 5 is equal to, those go away, 8 minus 3, and I get 5. Okay, getting closer. Now again, I'm solving for x. So let's get rid of this whole dividing by 5. And again, we could get rid of this fraction here by multiplying by 5. So we could clear our denominators by multiplying by that common denominator. Multiplying by 5 here again. 5 simplify, leaving me with just 2x minus 4 equals 25. And now we're right back to a two-step equation. Let's get the negative 4 over by adding 4. So here we have, bringing down my 2x, negative 4 positive 4, see you later, equals 25 plus 4 is 29. Okay, and then the last step, I don't want 2x, I just want x. Let's divide both sides by 2. X equals, now 29 doesn't go into 2 doesn't go to 29 evenly, so we could actually just leave this one just like that, 29 over 2. And we could leave it as an improper fraction. Alright, let's look at our next example. So we have two examples left here. So we got 2x plus 5 minus 6x equals negative 2x plus 6 plus 1. Alright, so this time we have variables on both sides of the equation here. So if we look at, we have a 2x, negative 6x, negative 2. So we have variables on both sides of the equation. Okay, so let's look at the left side first. If you can combine any like terms here, let's combine. So if you notice, we have the 2x and negative 6x are alike. So this is the same thing as saying 2x minus 6x. So 2x minus 6x here is going to be negative 4x plus 5 equals. And now let's combine anything on this side that are like terms. So the like terms on the right side here, if we're looking at these, are going to be the positive 6 and positive 1. So we're going to say negative 4x plus 5 equals negative 2x plus 7. Okay, so we're getting a little closer. So now we want, in order to solve for x, we want the variables or the terms with the x on one side. Doesn't matter which side. So let's say I'm going to keep this my x side here. So I'm going to bring this negative 2 over to the left side. So how do I bring negative 2 over to the left? So right now I'm subtracting 2x on the right side. So in order to bring the subtracting 2x to the left, I'm going to have to do the opposite, which would be to add 2x to both sides. So I'm going to add 2x to both sides here. So now we have negative 4x plus 2x is negative 2x. Nothing happens to my positive 5 equals, these simplify, leaving me with just 7. Okay, getting closer. Now we're back to a two-step equation. So let's isolate the x. Let's get rid of this positive 5, bring it on over. So minus 5, minus 5. Now here we have negative 2x. Positive 5 and negative 5, see you later, goes away, simplifies. 7 minus 5 is 2. And one last step, we're going to divide both sides by a negative 2 here. And we're going to say that x equals, so negative 2 divided by negative 2 is 1. 2 divided by negative 2 is equal to negative 1. So x equals negative 1 here. So I'm going to concentrate on this one first, this piece here for a second. Once you've combined like terms, okay, so I'm just going to take the technical difficulties. So looking at this step here, the -2, or this here, combining like terms part, you can actually do this in one step here. So looking at this part here, I subtracted added 2 to both sides, then I added 5 to both sides. So I want to try to do this in one step. I'm going to bring the x's over to one side, I'm going to bring the -2 over that way, and I'm going to bring the +5 over this way, all in one step. So again, to get the -2 over, I'm going to add 2x to both sides. So that takes care of the x's. That will bring all my x's to one side. And then to get the +5 over to the other side, I'm going to subtract 5 from both sides. So this here will get rid of that piece and that piece, leaving me with just the x's on one side and the constants on the other side. So let's put those together. So -4x plus 2x, we have -2x equals +5 minus 5 is 2, and then that brings me right to this step here. Okay, so this is a -2x. Alright, so you can combine those two steps and those two steps in one if you like. Just be careful. Let's take a look at another example. Last example. So 3x minus 8 equals 5x plus 4 minus 8x. Alright, so we have multiple terms on both sides. We have variables on both sides. Let's go piece by piece. Can I simplify anything on the left-hand side? Can I simplify anything here? 3x minus 8? Well, there's nothing I can combine here. 3x minus 8, they both are not like terms, so there's nothing else I could do here. What about on the right side? I got 5x plus 4 minus 8x. Alright, so I got two terms with the x here, so I can combine these. So let's go left to right. So I'm going to say, okay, 3x minus 8, that's my left side, equals, now let's combine these two. 5x minus 8x is -3x plus 4. Okay, so I'm going to utilize the same strategy I did before. I'm going to bring the x's on one side and the constants on the other side all in one step. So I'm going to bring this -3x to that side. That will bring all my x's to one side. And then I'm going to bring this -8 to that side. That will bring all my terms without x's or my constants on one side and the other side. So how do I get this -3x over to the left side? Okay, I'm going to do the opposite. Very good. Plus 3x. And how do I get this -8 over to the other side? Good, we're going to do the opposite again. So add 8 to both sides. Okay, and let's see what we're left with. So 3x plus 3x is 6x. -8 plus 8, see you later, we got nothing left, equals -3x plus 3x, that goes away also, +4 and +8, we get a +12. Alright, so now we got 6x equals 12. I don't want 6x, I just want x. So I want to get x equals, divide both sides by 6. My 6's simplify, leaving me with x equals 2 as my final answer.